Welcome to the online lectures for software engineering. In today's class, we'll be discussing design engineering. Now, what is design engineering? Now, this design engineering, it encompasses that this design engineering is made up of different principles, different concepts, and different practices. So design engineering is made up of these three things. Now these three things, they lead to the development of a high quality system design. Now the design that is going to be developed, that is going to be a high quality design. So that is the definition of design engineering. Now within this design engineering, we are going to see next topic. The first topic is designing within the context of software engineering. Now what happens within the previous classes, we have studied requirement engineering. Now within requirement engineering, we have seen you're going to gather all the requirements. There are 7 steps within requirement engineering. So now within this, what happens once all the requirements have been analyzed? So all those requirements, when you have analyzed all the requirements, you are going to start with the modeling part. Now, when this requirement analysis is done, when you have analyzed all the system, the entire components, then you have done the modeling part. After this modeling, this designing part, this is the last step. And this designing, it is going to set the stage for construction. That is, after the design is complete, you can go for construction. It sets the stage for construction. Now, designing within the context of software engineering. So this is what I told you. One software requirement are analyzed and modeled. Software design, it is the last software engineering action within the modeling activity, and it is going to set the stage for construction. That is when all of this is done, you can go for the construction stage. Now, whenever you're going for design engineering, this design engineering, it produces 4 different designs. Now, what are those 4 different designs? That is data and class design, architectural design, interface design, and component design. So these are 4 different designs. So what is the first class? That is the data or the class design. Now this data or class design, it is going to transform the analysis model. It is going to transform this analysis model into class realization. I'll give you an example of what is class realization. So this line over here, this is called as realization relationship. This is called as realization relationship. Now within this, you've got one printer class and you've got a printer setup. Now if you have got a printer but you have not done the setup of the printer, then this work of printer is not useful. So this printer setup, it executes the printer. So this is what this data and this design class, it is going to transform the analysis class model into class realization. This it transforms it into class realization. Now this is the first step, that it transforms into class realization. The second step is that it is going to also identify all the different necessary data structures. Now what are data structures? What type of data that you're using? It is going to identify that also. Now when you've got all the data structures, you're also going to focus upon the different relationship. Now one relationship that was already studied is the realization relationship. So you're going to also identify the different relationships. Now this data and design class, that is, these are the three steps within the data and class design. Now a part of this data and class design, it can be implemented by the second one. The second one, that is your architectural design. Now within this architectural design, this what is the task within the architectural design? Now this architectural design, it is going to identify all the relationships. Now we have seen that, I've told you that the data and class design, it can work in conjunction with the architectural design. So when you're identifying the relationships, it is working with the architectural design. So it is going to identify all the relationships between the different structural elements. Now what is a structural diagram? The structural diagram, it is, the example is a class diagram. Structural diagram you can say, or you can say the elements. So it is going to identify the relationship between the different structural elements of the software. Now this architectural design, as the name is architectural design, it is also going to identify the different architectural styles. Now this architectural styles we are going to study after we complete with the design engineering. It is going to identify the different architectural styles that you're going to use and the different design patterns. You're going to have a list of design patterns and architectural style. So within design, we're going to study design pattern. After that, we're going to go for architectural style. So this architectural design, it is going to tell you that what are the different architectural styles and different patterns that you're going to use so that you can develop a system. The next one is the third is interface design. Now what is interface? Interface is your point of communication. So this interface design, it is going to identify how the software is going to communicate. Now who is going to communicate with the software? The human is going to communicate. That you're going to identify how the human is communicating with the computer or with the software. So you can say that this is going to focus upon human computer interaction. Now this interface is also going to tell you what is the flow of information. Now what is flow of information? How information is flowing from one component to another component. We have studied within the analysis model, that was also called as the requirement model. We have studied their different models. The 4 different models we have studied: scenario based modeling, class based modeling, we've studied behavioral elements, and we have studied scenario flow oriented elements. 4 different elements we've studied. So within this 4 different elements, how the information is flowing from one element to another, that is going to identify. And what is the behavior of the system? How is the behavior is going to identify? The behavior can be identified by making use of the use case diagram. Now when you're making use of use case diagram, that is, it is going to focus upon the different use case scenarios, the different usage scenarios, plus all the different behavioral elements. So this is your interface design. The fourth design is now the fourth design is component level design. Now what is this component level design? This component level design, it is going to transform all the structural elements. Now when we are, where did we identify the different structural elements? The different structural elements were identified within the architectural diagram. So it is going to transform all of the structural elements. It is going to transform all the structural elements that were identified within the architectural design, all the structural elements of the software architecture into a procedural description. Now, what is a procedural description? What is going to happen within a particular procedure? That if suppose you are opening the door. So what is the procedure for opening the door? You're going to give a procedural description of all the components. And this procedural description is going to take input from class-based elements, flow elements, behavioral elements. So this is going to be the basis for component level design. So what is going to be the input that is going to be taken? The input that is going to be taken is going to be your class-based elements, your flow-oriented elements, your behavioral elements are going to be the input for your component level design. Now, whenever you're focusing upon this 4 different design, you're going to make different decisions that is going to affect the success or failure of your software that you're going to design. Now, you can say that one word in which you can define what is a software design. That one word is quality. Quality is the word where you can define the importance of software. Quality is the importance of your software design. So we have studied 4 different designs: data class design, architectural, interface, and component design. Now this is your diagram that is going to translate the requirement model. Requirement model is also called as your analysis model into the design model. So you have seen that this is your design model, 4 different architectures: the data class architecture, architectural design, interface, and component level design. Now, which of the different elements are going to act as input? So within this analysis model, we have studied 4 models: scenario based elements, flow oriented elements, class-based, and behavioral elements. So within this, as these 4 are going to be input for your design model, we'll see which particular design is going to focus on which particular model. So we'll start first with the scenario-based elements. Within the scenario-based elements, it is your input for interface design. So 1. Then scenario-based element, we can see there is only one arrow going from scenario-based elements. So we'll go to the second one. Within the second one, I'll take a different color. Flow oriented elements. The flow oriented elements, it is input for component level design. This is one that you've considered. Second is interface level design, and third is architectural design. Then we'll go to to the third one. Now within this third one, class based elements, it is input for architectural design. It is input for data and class design. 2 are going out. Then fourth one is your behavioral elements. Now within this behavioral elements, it is input for component level design, and it is input for interface level design. So we've considered all. Okay, we have, I guess I did not take this class-based elements. One more line going here. That is third one. Let me write for third again. This is 3. I'll check. So this data and class design, it takes input from class-based modeling. Architectural design, it takes input from 2 and 3, that is flow-oriented elements and class-based elements. Interface design, it takes input from scenario, flow-oriented elements, and behavioral elements. Component level design, it takes input from your flow-oriented elements, behavioral elements, and class-based elements. So this is how you're going to transform your requirement model, or we can say your analysis model, into your design model. By taking this input, this is your output of your design model. Next topic is design process and design quality. Now, whenever you're going through design, this design, it is an iterative process. Now, what do you mean by an iterative process? That is, it is a continuous process. Iterative means it is a continuous process that is going to take place until the entire software is being completed. Now, by when you focus upon design, this is going to convert the entire design into a blueprint for construction. As I said, the design is going to set the stage for construction. Now, whenever you're designing, the first step of design, it is going to be at a higher level of abstraction. Now, what do you mean by a high level of abstraction? High level of abstraction, it means that you're going to give less detail about the design that you're making. Now, as this iteration occurs, that is in multiple iterations, when this goes to nth level, within this, you're going to have a low level of abstraction. Now, low level of abstraction means you're going to give high detail of the design that you're making. Now, this design and quality, now the design should provide you with a complete picture of the software. That is, whenever you're focusing upon design, as we have said that first we've studied requirement engineering, you're going to analyze all your requirements. You're going to analyze all the requirements. You're going to do the modeling. After that, you're going to go for design. So this should have a complete picture of the software. Now, complete picture, what are the complete picture? That is addressing the data. What type of data you're using? You should have a clear picture. What are the different functions? You can say the different tasks that are performed by the software. Behavior means how the software is going to behave based upon a particular environment, or based upon an external environment, how the software is going to behave. You're going to identify that. So this should have a complete picture from an implementation perspective, because after your design, you're going to go for the construction phase. So that is why it should have a clear picture of all the different things. The next one, this is the characteristics of design. This is important for 3 marks. What are the different characteristics of design? So there are 3 characteristics that is going to have a guide for your good design. That is, you can say that this 3 designs, these 3 characteristics, these are also considered as goal for design process. So going on to the first one, the first one is the design must implement all the explicit requirements contained in the requirement model. What is requirement model? Requirement model is your analysis model. So within your analysis model, what are all the requirements that were implicitly stated? Explicit means that were not actually mentioned, like the performance should be there, the software should be accurate. All of the things should be present whenever you're making the design. So this design should implement all the explicit requirements, like the performance, like the accuracy. All of the things need to be implemented that were there within the analysis model, because this analysis model is going to have all the requirements that was stated by the end user, and it must accommodate all the implicit requirements. These requirements are the ones that are actually stated by the end user, or implicit requirements that are desired by the stakeholders. Now it is going to have all the 2 types of that. That is the one that was stated by the end user and by the stakeholder. So it should have 2 types of requirements implemented, that is the implicit requirements and the explicit requirements. The next is the design should be readable, understandable guide for those who generate code and for those who are going to test. That is, you're going to have the coders and the testers. Whatever design you're making, it should not be very complex. It should not be complex. It should be easily readable, understandable, so that the people that are going to code, they do not have any problem in understanding what the code they need to implement, and the people that are testing, they should also have a clear picture of what the software is. It should be in very simple, clear terms, so that they can understand and build the software accordingly. Then the third characteristic is this design should provide you a complete picture of the software, addressing the data, that is what type of data is used, functions, behavioral domain. From implementation perspective, we have read this line within the previous slide, that is what is design and quality. So these 3 are actually the goals of design, and each of this characteristic Now whenever you're focusing upon design, so all of this different characteristics of design that you've seen, this should be implemented when you're going for design, not when you've completed the design. So this should be implemented while you're designing or before the design is going to commence. So these are the characteristics, and this is an important answer for 3 to 2 marks. Now the next one is quality guidelines. Now what are guidelines? Guidelines are few steps that you need to follow whenever you're building a software. Now the design should exhibit an architecture, that is within the design you're going to make an architecture. So this architecture, it need to encompass of a few things. What are those things? It should have a recognizable architectural style. Now architectural style means, suppose you're you're refurnishing your home, so you're going to have different books or different patterns. For if you're designing the kitchen, if you're designing your room, you're going to have different styles that you're going to implement, where the study room should be, where your bed should be placed, your study area, where your bed should be placed, where is the lighting, where is the window. There are different styles based upon every yeah, based upon every room. So there are different styles and different patterns are implemented. Like there are different types of doors, there are different types of knobs, different types of wardrobes. So all of those things, whenever you're designing a design, they are also going to have different styles and different patterns are there. So this design, it should be created using recognizable, that is, you're going to have different styles. So this style that you're implementing, it should be the one that is actually recognizable, that people know of, so that the coders and testers can identify and work on them. So it should be a recognizable style and pattern that you're developing. This architecture styles and patterns, this we are going to study in detail within the next chapter. Now this design is composed of components. What are components? Different parts, or you can say different modules. So the different components should exhibit good design characteristics. Design characteristics, these three characteristics. From these three characteristics, you need to have all the components need to have these characteristics implemented. Then the next is, it can be implemented in an evolutionary fashion. With an evolutionary fashion, which particular model we have studied? We have studied the spiral model. Now within the spiral model, what you do? You are going to keep on developing the software. So this, if suppose within the first iteration you have developed a model, you're going to identify what are the risks in them. You're going to again make another prototype. You're going to either discard the entire thing, or you can take a few items from the previous prototype and again implement it. Then this process is going to be continuous until the entire software is complete. Next is, the design should be modular. Modular means it should be within different that is, it should be logically partitioned. The different elements need to be partitioned. Now modular means, if you've got one specific design, you're going to split it into small different modules, so that you can focus upon different entities. So the design should be modular. It should be broken down, it should be able to be broken down into different components or different parts. Then the next one is, a design should contain distinct representation of data, architecture, interfaces, and components. So what these were the four different design that we have already studied within the beginning of the class, the first slide. So this design should contain four different types of representation: the representation of data, the representation of architecture, interfaces, and components. Then the next one is, this design should lead to data structures that are appropriate for classes. Now appropriate for classes means, this data structure, it should be relatable to your class. It should be one that is recognized, that can be used, that are appropriate, we can say, that are appropriate for your class. The data structure that you're using, they need to be appropriate for class to be implemented, and they need to be drawn from recognizable data patterns. Now these data patterns are also defined, that how you, as time passes, you're going to have different architectural styles, different patterns are implemented. So the styles and patterns that you are using, they need to be recognizable data patterns. Now why we're using, every time why we are focusing on recognizable data styles and patterns? Because when you have a specific data pattern, you can identify what are the prospects and consequences of a particular data pattern, so that you can focus upon them. If you're using an unrecognized data pattern, it is going to be difficult for construction and even for testing. That is why you're going to focus upon recognizable data patterns. The next is, our design should lead to components that exhibit independent functional characteristics. That is, one component, it should be able to do one task at a particular time, or that should do only one task. The next one is a design should lead to interfaces that reduce the complexity of connections. Now, within the previous class, we have studied cohesion and coupling. We have focused upon, we have studied what is cohesion and what is coupling. So you need to focus upon this. The next is a design should be derived using a repeatable method that is driven by information obtained from software requirement analysis. Now, this particular design, that is whenever you're making a specific design, you need to focus upon repeatable method. That is whenever you're making a design, it is going to be similar to some specific architecture or some specific software that was already designed. So whenever you're making a software that is similar, so you need to use a repeatable method. Now whenever you're reusing, you are going to reduce the cost and you're going to reduce the time. So a design should be derived using a repeatable method that is driven by information obtained from software requirement analysis. So that is the next point. The next one is a design should be represented using a notation that effectively communicates its meaning. Now, a notation means suppose you can use a specific model or you're using a specific pattern. So whenever you're using a particular model or a specific notation, this particular notation, it should be able to tell you everything about the model, because this design, it is going to focus upon a complete picture. So you're going to take the one that is actually going to convey all the information. It should convey all information about the different data, different functionalities, everything should be addressed. So whatever design notations you're using or different models you're using for representing the design, they need to be able to communicate its meaning. That is, suppose you want to know how the business is going, so you're going to plot a graph, that is whether it is going upwards or whether it is going downwards. So a graph that is going to convey the meaning, you need to use such type of graph or such type of notation. The next is different quality attributes. Now within the quality attributes, the Hewlett-Packard developed a set of software quality attributes. Now these quality attributes are called as FURPS. That is acronym for functionality, usability, reliability, performance, and supportability. Now what is functionality? Functionality, it is going to tell you what is the entire feature set of the different capabilities of the software that it can perform, the entire feature set. And what is the security? Now security means the overall security of the software. That is what is functionality. Now the next is usability. Now what is usability? Usability is going to tell you how the person that is using the software, how efficient it is for him to use the software. That is, you're going to identify the human factor for using the software, what is the ease of access, and you're also going to focus upon the aesthetics of the software, how it is going to look, then whether it is consistent or not. Consistency means whether it is complete, the software should be complete. And it also focuses upon the documentation, that is the entire documentation of the software. Now within the documentation, you can have the installation guides, you can have troubleshooting guides, so that is your documentation. Then the next one is reliability. Now reliability means how much the person that is using the software, that is the human, how much he can be dependent upon the software, how much he can depend on the software is called as reliability. How much he can depend upon the software. Now when you're depending upon the software, it is also going to identify what is the accuracy of the software, whether you're depending upon the software, whether it is giving you exact results or not, and what is going to happen when your software is going to crash. That is called as MTTF. MTTF is the mean time to failure. MTTF is mean time to failure. Now what does this MTTF means? The mean time to failure, it means that what is the ability to recover from failure. Now ability to recover from failure, it means that now if suppose you're using Microsoft Word, you're making a documentation for your project. Now if suppose the current goes, you're not connected to a UPS system, or you're not connected, you're not working on the laptop. So when the current goes, the system is going to shut down if there's no power backup. So when the current comes back, whether the work that you have done, whether it is going to be saved or not. Now within Word, there is this automatic saving feature that is going to save your work. So what is the MTTF? Yeah, that you're going to identify, and you're also going to identify what is the predictability of a program. How much is the software is predictable? You can also have this dictionary. So within the word. So what is the predictability of searching the words? That is predictability. Now performance. Now within performance, you're going to identify what is the performance of this. Now this performance, how it is going to be measured. The performance is measured by the processing speed, how it is going to process your input. Based upon the input, how fast it is giving you the output, that is your processing speed. Then what is the response time, within how much time it is going to generate the response. Whenever you do a Google search, it is going to give you the response time. With the result is given in some microseconds or a second, it is going to give you the response time. Then you're also going to focus upon the resource consumption, that is how much memory is being used, that is your resource consumption. And also the efficiency, the throughput and efficiency, that your performance is going to be calculated by this processing speed, response time, resource consumption and efficiency. Based upon all that, you get to know what is the performance, whether it is 90%, 99%, 100%, that is your performance. Then the next one is supportability. Now the supportability, it is going to have this feature for program extension. Now what does program extension means? That is whether you can add another feature or not. Program extension, how your software is adaptable or not, the adaptability of the software upon different platforms, and serviceability, that is how you're going to provide service. Now these attributes is these three combined is called as maintainability. So these three are called as maintainability. Now apart from this maintainability, you're also going to focus upon testability, that is how well your software can be tested, whether it is compatible, compatibility, and also the configurability. That is what are the different configuration, software hardware configurations are there. Now this are maintainability, testability, compatibility, configurability. So these are the four functions that is used in the supportability function. Now this can also have what is the ease of installation, that is whether the installation process it is very long or it is very easy, that is going to be identified. That is called as your ease of installation. So these are your different quality attributes. Now these quality attributes, they need to be applied before you're going for the design. This quality attributes, they need to be considered as your design commences. That is when you're beginning with the design, you're going to start that, not after your design is complete. So within the next class, we'll be focusing upon the different design concepts. So this is the end of today's class. Thank you.